All right, so I've got a function over here. I made a little graph. It looks like x squared maybe, but I don't really care about exactly what function this is. This is my starting function that I'll sometimes call the parent function. It's like the original. And the whole purpose of today is to be able to transform this function by sort of moving it around. The first transformation that we might do is to move it upward. So for example, if we wanted to move it up by 4 grid spaces, what you would do is take the original function, f of x, and just add 5. Did I say 4 before? I'm not sure. You add 5 to all the x values, to all the y values, to make it go up by 5. You might want to make it go down by 5, so go back to your original parent function, and if we want to shift it down by 5, I'm sure you can guess this. It's the same thing. Take f of x, but we want it to go down, so we subtract 5. Okay, that's not so bad. Maybe we want to take the original and move it to the left by 5. Obviously, you can do this with any number, but we're going to move it to the left. Instead of adding or subtracting to the output, to the y value, we're going to take our function and we're going to add or subtract to the input, which is x. Now, the one thing that's real weird about this is any changes you make to x are backwards of what you would think. So going to the left, we actually add 5. Totally feels backwards. That only happens inside the parentheses when you're going left or right. Speaking of right, if we want to start with our original function and move it to the right, I changed the color. If we want to move it to the right, here's what we do. We take f of x, and we take the x, and again, it feels real backwards. Going to the right means minus 5. The backwardsness only happens inside the parentheses. Then we have the option to stretch or shrink our function. So maybe I want to take the original function and sort of shrink it down, right? I want to make it not as tall. I can do that. No, I can't. Hang on. Now I got it. Oh yeah, movie magic, baby. I can shrink it down or stretch it to make it taller. So this is basically multiplying the y values to either make them taller or shorter. If you want to multiply to make it taller, that's a stretch. You could do something like multiply by 5. So you would take the original f of x, and all the y values get multiplied by 5 by just putting a 5 in front. 5 times f of x. Or if you want to shrink it to make it 1/5 as tall, or 5 times shorter, you would just put a 1/5 in front. That would shrink it down. The last thing we can do is a little different. This is a reflection. So again, I can go back to my movie magic over here. A reflection is where you take it and basically flip it upside down or flip it left and right. We call the flip up and down a reflection over the x-axis because this is the x-axis and we're flipping over it. Feels a little backwards again. It is what it is. If I want to reflect over the x-axis, what I'm doing is taking all the x values and taking all the y values because I'm flipping up and down. So I'm taking the outputs and making them the negative of what they used to be. And again, it feels sort of backwards, but if I want to do a reflection over the y-axis, that means I'm actually flipping the x values. So take the x's and make them negative. So I kind of like this little cheat sheet to basically show you how to do all of the different things. But you might want to combine multiple transformations into one, and you can do that as well. There's sort of a nice way to show all the transformations at once, which is to create this like combined function. I tried to use the color coding to help. This is basically just showing all the different transformations in one. It's the idea that, okay, I can add or subtract at the end to move up or down. That's the plus k. Add or subtract on the inside to go left and right. That's the plus or minus h. Multiply at the beginning to stretch or shrink. That's the multiply by a. And these different negatives let me reflect over the y-axis or over the x-axis. Don't get hung up on the letter choices. I chose A, H, and K. Other people will choose different letters. Everyone kind of writes it a different way. But whatever sort of cheat sheet you want to make for yourself, you can create something that looks sort of like this as a way of memorizing all the different transformations.